versus another year known for its drought, then they might perhaps take some precautions.
Yes.
The data collected from the Nilometer did have one practical use. By creating an objective record of the river's behaviour, it allowed the rulers of the time to calculate how much tax to levy on Egypt's farmers. But whatever its uses, what I love about the Nilometer is how it shows that to understand the world, you have to build devices to measure it.
If you think very hard, it's never obvious that measurement can make sense of the world around us. The world appears, as a Western philosopher once put it, like a buzzing, blooming confusion. And the idea that we as a group have tools which are reliable, which have sufficient integrity, which have an intellectual grip that can make sense of the basic phenomena we see around us, that's an astonishing idea.
And one medieval Islamic ruler made measurement a personal obsession, giving it a scale and ambition that was truly unprecedented. His name was El-Ma'mun, and he became the caliph or ruler of the Islamic Empire in 813 AD. El-Ma'mun lived in a culture without portraiture, so all we have are later impressions of what he might have looked like. El-Ma'mun funded a range of scientific research, but one particular project was a personal favourite of his. And given that he ruled over such a large territory, it's hardly surprising what it was: map-making.
In the second decade of the 9th century AD, El-Ma'mun commissioned a new map of the world, and his scientists did a pretty impressive job. It was a vast improvement on all maps that had come before. What we see here is that they've really got the Mediterranean, its shape and how it links in with the Black Sea, the Middle East, even the whole of Asia as far as China and Japan. They've even got the Indian Ocean and the east coast of Africa. It all looks pretty impressive for the known world at the time. Of course, what El-Ma'mun ultimately wanted to know was how much of the Earth as a whole did he possess? And this begged the question, just how big is the Earth?
It's a sign of amazing ambition that groups of scholars and craftsmen together can, as it were, capture the world. Where does that ambition and that confidence come from? Part of it comes from religious faith. Because the world was made by someone a bit like us, but much smarter, if we're smart enough, the thought was, we could probably make sense of a bit of what he did. And that's very clear as a motivation in a lot of Islamic, as in a lot of Christian science.
And more specifically, the practice of Islam demanded that its followers have a very clear idea of the size and shape of the world.
Now, this is crucial information for Muslims because wherever they are in the world, they need to know the direction to Mecca for their prayer. This is known as Al-Qibla. Now, over such a large territory, finding the direction to Mecca is not a trivial problem.
This problem was wonderfully illustrated when a mosque was built recently in Washington, D.C. Some worshippers were confused because the direction they were told to face when praying was slightly north and not southeast as they expected. After all, Mecca is southeast of Washington, and on a flat map, it does appear to lie in that direction.
But on a curved sphere, the shortest distance between any 2 points follows what's called a great circle. So, for example, this great circle line between Washington and Mecca is quite different to what you might expect. So the direction to Mecca from Washington actually points slightly northeast rather than southeast. Of course, this is complicated stuff, But the key point for Islamic scholars is that knowing the direction to Mecca requires a knowledge of how steeply the earth curves. And that means knowing how big it is.
So Al-Ma'mun commissioned his very best scientists to measure it.
Hello.
Hello.
Mr. Sami. I'm Jamal Khalili. Nice to meet you.
To understand how they did it, I'm meeting up with Professor Sami Chaloubi from Aleppo University in Syria, who's an expert in early Islamic science.
Come and join me.
هلا عندما قسم هاي على 7.5 عندما قسمها على 7.5
Professor Chaloubi began by explaining the measuring technique, which Al-Ma'mun's scientists first used and which they had inherited from the Greeks.
We're now talking about the earlier
Yes.
Aristophanes technique of measuring the circumference. It was repeated again by the Abbasid astronomers, was to measure the distance between 2 points and then look at the angle of inclination of the sun. So in Egypt, in Aswan down in the south, they regard the sun as being vertical. This is, near to the equator. And they worked out how far away from the vertical the sun was if they measured it from the north of Egypt in Alexandria, which is on the Mediterranean coast.
Al-Ma'mun's astronomers repeated the Greek experiment in Syria and Iraq by measuring the angle of the sun in the sky at noon at one known location. They then walked due north to a second location, carefully measuring the distance they travelled. At the second location, they once again measured the angle of the sun at noon. This angle would have been slightly smaller than the first one. With these figures, Al-Ma'mun's astronomers were able to estimate the Earth's circumference. They got a value of 24,000 miles, within 4% of the correct value. Not bad, you might think, but this method was flawed and ultimately unreliable. The main problem with it was that measuring the distance between two locations was incredibly difficult. It could only be done by the unreliable method of counting paces as you walked through the burning desert. A more reliable and sophisticated method for estimating the Earth's size was needed, and 2 centuries after Al-Ma'mun died, it came. What made it possible was a great leap of imagination, and the fact that by 900 AD, much of the world's mathematical knowledge had been translated into Arabic, so scholars could scrutinize and improve on it.
Out of this obsession with scholarly learning came a true mathematical visionary, Abu Rayhan Muhammad ibn Ahmed al-Bayruni. And like all Islamic scholars of the time, al-Bayruni was obsessed with the science and mathematics of the ancient Greeks, Babylonians, and Indians. And because of the success of the translation movement, he had literally on his desk the great work on geometry by Euclid, Ptolemy's Almagest, the Indian text, the Sinhind, and the famous work on algebra by Al-Khwarizmi.
كان مكتوبة كتابة حطوا ورقة.
Professor Chaloubi has brought along the book in which al-Bayruni describes how he combined algebra and geometry with some very simple and practical measurements to solve the epic problem of how to calculate the size of the Earth.
بيروني the text from
This is his
القانون المسعودي.
the Mas'udi canon.
Yes.
This is Bayruni's canon, which I've been trying to get hold of, where he describes this fantastic experiment. And oh, you found the page.
Yes.
Having read al-Bayruni's description of how to estimate the size of the world, I wanted to try it for myself.
First, he had to find a fairly high mountain from the top of which he could see a flat horizon. In this case, the sea.
What I love about this story is that with a few simple measurements around this small mountain peak, you can work out the size of the whole world. Al-Bayruni's first step was to work out the height of the mountain. He did this by going to 2 points at sea level, a known distance apart, and then measuring the angles from these points to the mountain.